Alright, this is the part 1 review key. We've been working on this all week, and use this to work out the second form if you need to. Okay, so once again, this is part 1, starting with cosine x, sine squared cosine x. I've shown you most of these, but I figured if y'all wanted to see an explanation so you can get the concept down even better this weekend, I would make a movie. Alright, so here we go. Alright, y equals cosine x. I do the derivative to both sides. Okay, I get y prime, and you should know this. You get negative sine x. Alright, here we go next. Let me zoom in a little bit. Try to stay in between this. Y equals sine squared cosine x. First we're going to write it nicely. And I think that we've had some struggling trying to understand, when is this a double chain rule? Well, I'll show you that in a second. I'll answer that question in a second. Alright, so what we have here is one thing 1 times thing 2. And both of these are more than x. So it's a thing 1 times thing 2. We're going to do alright, product rule. So once again, the derivative of y is y prime. The derivative of the first, this is a chain rule because it has an outside and an inside. So derivative of the outside, let's work it off to the side. Okay. The derivative of the outside is 2 parentheses sine x. That's the derivative of the outside. I keep the inside, and then I take the derivative of the inside. Cosine x. Well, what if I mistakenly thought this was a double chain rule? Well, I would just take the derivative of the inside of the inside. Well, what's the inside of the inside? It's x, so what's the derivative of the x? 1. So if you mistakenly do a double chain rule, it, meaning 1, does that matter? No. Okay? If you mistakenly do a double chain rule, it doesn't matter, because you'll be doing the derivative of something that's x, and you'll be getting 1. Now don't take the derivative of this again, because you take the derivative of 1, you get 0. But well, that's not the inside. We're talking about, alright, I do the derivative of the inside. Okay, now is there another inside of the inside? No, that's impossible. When you do your chain rules and you get 1, that's where you stop. Okay? Don't take it again and get 0. Alright, so we input that right here. Alright, I won't worry about the 1. The 1 doesn't matter. And then times the second. Okay, cosine x plus the derivative of the second, negative sine x, times the first, sine squared x. Now, I'm nitpicky. I like my answers to look good, so you don't have to do this, but you can. Obviously, that's cosine squared x. And that's a negative sine cubed x. And I can really just change that to minus. And I'm good to go. Those are both correct. Alright, moving on. This next one, number 3. This one is a double chain rule, okay? But it's thing 1 divided by thing 2. It's thing 1 divided by thing 2. Alright, so this would be a quotient. Alright, quotient rule is dt times b minus db times t over b squared. So let's get to it. Right off the bat, when I do my dt, which is the top, oh, I'm sorry, I said thing 1 divided by thing 2. I meant to say there's a top divided by a bottom. So when I go do the derivative of the top, I first of all see that it's not really written nice, so let me go ahead and write it nice before I even start. And then I say, whoa, that's big. So I'm going to take it off to the side. And I'm going to start by taking the derivative of the outside and working my way in. Keep the inside. Now I take the derivative of the inside. Well, that's another chain rule, and there's another inside, so I know I'm going to keep that inside. Now the inside I kept, I have to take the derivative of again because it's more than x, and the derivative of that would be 2. Now the number 2 doesn't have an inside to take the derivative of again, so I'm done. You just work from the outside in, guys. Work from the outside in. So I'm going to take this. I'm going to put it right there. And I see that my brightness is a little too high. Hopefully that helps. I'm sorry, guys. Man, that's a mouthful. Alright, so there's my dt times my b minus db cosine x, which would be negative sine x, times your top, t. All over your bottom squared. There you go. I like my answers to look nice, so I'm going to combine. No. I can't combine those. And I can't combine those. And I can't combine those. Well, never mind. The only things I can combine are here, here. It's all part of the same term. And these two negatives make a positive. So let's do that. Just to say we did. I don't like writing my squares like that. I much prefer them like that, but it's okay. It's faster. Alright, next problem. Number 4. Let's write it nicely. I know y'all don't like this, but we all have trouble with implicit differentiation sometimes, so write your y's as f of x's and you will have less trouble. That's all I can say. Alright, so we want to take the derivative. I know I haven't used the proper notation for the most part. I apologize. We're taking the derivative of both sides and we're working from the outside in. Outside, keep the inside. Outside, keep the inside. That's the process, because this is a double chain rule. Derivative of the outside is 6 sine f of x. Keep the inside. Alright, and this is 1. Now, derivative of the outside, cosine, keep the inside. Now, the brightness is still a little too high. Sorry. Derivative of, I did the derivative of the outside, so I did the derivative of the outside. I kept this inside. So what I kept, I derive again. Now I'm not going to take the derivative of a derivative. That would be silly because I'm doing the first derivative. Since this is already the derivative, I'm done. Alright. So there's that. The out can derivative of the inside, the out can derivative of the inside. That's the process for your double chain rule. And if you end up here, you're done. Alright, negative sine x. So now, keep your eyes on the prize. There's my prize, the illustrious derivative. I want that by itself. Now notice what's connecting all this. All this is a, I'd like to call it a factor. Okay, it's a factor because it's multiplying. So what we're going to do is we're going to divide it. And notice right now, instead of f of x, I'm going to use y. Because it's easier to write. No other reason. And that's it. It's a factor, so I divide it. And now it's divided on the opposite side, and I have my solution. I think that one deserves a boom. Alright, moving on. Number 5. I like number 5. It's a great question. I mean, this is an ellipse. Okay? So it's pretty cool. It's going to make an ellipse. And you can find the slope of the tangent line with the derivative. So first we're going to write it nicely. I know you guys don't like this, but it's for your own good. And now we're going to break it down. That's a multiplying constant. That's a multiplying constant. So I don't even need to take the derivative of it, to be quite honest. I'm deriving that, and I'm deriving that, and I'm deriving that. Actually, what am I deriving on the 9? I'm actually deriving x to the 0 power. Okay? So the constants just come down. And even this constant can come down, but we all know what's going to happen there. I derive, multiply, and end up with 0. I derive, multiply, I end up with, well, 16 times 2. Alright, and then I keep the inside the same because that's more than x. And now it's to the first power, which I don't have to write, minus 1. Okay. And now derive the inside. And now here, this is simple power rule, so times 2, x to the first power. Bring down your plus sign. Okay? So there you go. Let's write it nicely and let's get to work. 18x plus 32 y prime equals 0. There's my goal. There's my prize. Let's get it. Let's get this on the other side. 32 y prime equals negative 18x. Let's get this on the other side. It's multiplying, so I divide. Y prime equals negative 18x over 32. It's not important, super important to simplify, but it's kind of like a pride thing. So have some pride in your fractions. If you don't have pride in your fractions, you're not going to do as well as you normally would. Let's get them simplified. So this becomes 9 over, 9x. 9x over 2 into that is 16. Yeah. 16y. Negative 9x over 16y. Alright. There we go. I hope that helped. Really, yeah. Looks good. Alright, let's keep moving. Email me if you have any questions about the problems that are on the Unit 2, the second review. I've got my email up all day today. Alright, so I can write this a little bit nicer right here, because I know that's a function of x. All those parentheses. Still much better to write it like this. Anyway, before I take the derivative, I know that's simple. I'm good to go with that. Derivative sine is cosine. But now you have thing 1 times thing 2. Yes, this is one thing. It's a second all by itself. It is a term. It's a factor as a term. So it counts as one thing. It's just a big thing. A big old joker. First, second. Let's set up our product rule. D1 times 2 plus D2 times 1. So D1 is 1 times 2, 1 plus tangent I'll just write y because I don't need to do anything on that. Plus d2. Now this is kind of scary, so we can do it off to the side if we need to. So derivative, let me separate my work here. 1 plus tangent y, or sorry, tangent f of x. The parentheses don't matter now. Okay, I'm just taking the derivative of that whole thing, which is the derivative of 1, which is 0, and the derivative of tangent, which is secant squared. But hold the phone, that's an inside more than x. So I keep the inside, and then I do the derivative of the inside, which is f prime of x. Okay? Now if I do it like this, I'm done. When I whap it in there, I'm going to write it nicely. I'm going to write it but no, the y is inside the secant, not the y prime. Okay? Now the first is x. We knew that. Alright. So there's your derivative. Now what's our prize? Y prime is the prize. So let's write it nicely before we do any more work. Cosine x equals 1 plus tangent y. And I'm going to move this out front, plus y prime x secant squared y. Okay? Alright, so this whole thing I can minus over. I can keep it in the parentheses and minus, or I can just make them both minus. I'll make them both minus. Cosine x equals, or minus 1 minus tangent y. Uh-oh, running out of room. Equals y prime x secant squared y. And this is all multiplying. It is a factor, so you can divide. Alright, so y prime is equal to all that good stuff. All that good stuff divided by this. Okay, so cosine x minus 1 minus tangent y, not tangent y, tangent y, tangent y all over x secant squared y. So there you go. Alright, cool beans. I bet, you know, that definitely deserves a boom. Alright. Alright, so here we go. This next one seems pretty easy, but let's break it down. First, I think it needs to be written nicely with your 4 sine f of x equals cosine x. Let's break down the parts. This is a multiplying constant. It's just going to come down in your answer. Okay? Sorry, this is crooked. Alright, and then I take the derivative of this. Well, first I start with the outside. The derivative of the outside is cosine. And in the insides, I'm going to keep the inside anyway. But it's more than x, so I have to take the derivative of inside again. I get f prime of x equals the derivative of cosine is negative sine. Now I'm going to convert back to y and y prime. The y prime is not in the cosine. It's outside of the cosine, multiplying to whatever the answer of the cosine would be. Now divide. This is a factor. No plus or minus, just multiplication. So y prime is equal to negative sine x. Ooh, I forgot my x. Almost made a mistake there. for cosine y. That was pretty simple. Oy. So, there you go. That's through number 7. Let's keep on motoring along. That's number 1 on the bottom. Here's number 8. Let's get crack-a-lackin'. Now we did this one in class and the answer was -1. I don't know if everybody got to see it though. Once again, I would rather just go ahead and make all these y's into f of x's. So you're taking a derivative of a function of x. No, that's f of x cubed, not x cubed. I'm taking the derivative of all these, okay, so d dx, alright, and then d dx, well that would be first, second, product rule, thing 1 times thing 2, this one, first, second, product rule, thing 1 times thing 2, and then that's just product rule. Not a product rule, power rule. Alright, so take the derivative of each part, each term. Plus the derivative of the first is 3 times the second is f of x squared. Plus the derivative of the second is 2 f of x, f prime of x, times the first, which is 3x, plus, I'm going to run out of room, derivative of the first is 6x, times the second, f of x, plus the derivative of the second is f prime of x, times the first, 3x squared, plus the derivative of x cubed is 3x squared, and that all equals the derivative of 0, which is 0. Yeah, that's a lot. So let me break it down. This was a D'Alkindin chain rule. And then this was just a product rule, D1 times 2, D2, that was a chain rule, times 1, and the next one was also a product rule, D1 times 2 plus D2 times 1, and the last one was just a power rule. So there you go. Alright, all equal to 0. Alright, let's rewrite this nicely and get f prime by itself. So 3y squared y prime plus 3y squared plus 2, well, these 2 and this 3 right here, make that 6. So 6 y prime x, or I can do 6x y prime. Okay, and then this one, 6 and that's 6xy plus 6xy plus y prime 3x squared. Okay, or 3x squared y prime plus 3x squared equals 0. Alright, so we got a lot of stuff right here. We want to get our y primes on one side. So I'm getting rid of, I'm going to minus this, I'm going to minus this, and I'm going to minus this. and that's going to give me 3y squared y prime plus 6x y prime plus 3x squared y prime equals all this good stuff. And then these all have a y prime, so we should all be used to factoring out our y prime. So y prime and you're going to divide all this out, okay? Well, you notice that they're the same on the left and the right. So when I divide it, if I factor out a -1 on the top, it changes all the signs. It's going to change all those to plus. I'm factoring out a -1 on the top. And then the derivative equals -1. Very, very interesting. Okay. Alright, that definitely deserves a boom. Alright, so getting the problems on the bottom, they require a little bit more understanding of a game plan. So let's get it started in here. Here is, like, I'm going to do this a different way. I'm going to just say that this is a constant, so I don't care. And then this becomes my first, and this becomes my second. But the constant was multiplying to the whole thing here, so the constant has to be multiplying to the entire derivative here. Okay? I'm not going to write that as f of x. I'm just going to make this a constant. Alright? And this is what I'm taking the derivative of. And that's fairly easy. It's a outside, keep the inside, then inside. And this is just a constant. If it doesn't have an x, you can think x to the 0. Alright, so let's do this product rule. Alright, d1 times 2 plus d2 times 1. Derivative of the first is 1, times the second is y, plus derivative of the second is y prime, times the first is x, and I'm done. Next, the constant just comes down, plus pi, derivative of the sine y is cosine y, but the inside was more than x. So derivative of the outside, keep the inside, now take the derivative of the inside, y prime, equals this constant, which is times x to the 0, which is 0. And now what we have here is y prime in a parentheses. You have to distribute. So that becomes 2y plus 2y prime x plus cosine y, y prime equals 0. I want this and I want this, so I need to get rid of that. So here we go, minus at the other side, 2y prime x plus cosine y, y prime equals -2y. Alright? And then factor it out, y prime equals 2x plus cosine y, because they both have a y prime, greatest common factor, get it out of there. It's reverse distribution. Okay, equals -2y, and this is a multiplying factor. I can divide the whole thing. Y prime is equal to -2y over 2x plus cosine y. Well, on this problem we were asked to find the slope and the equation of the tangent line at 1 over pi. So what is the slope of the tangent line? Well, that's the output of the derivative, so I need to take this x and I need to plug it in to this x. Alright, and I need to take this y and I need to plug it in to both these y's. Okay, so my slope ends up being y prime is equal to negative 2 times pi, negative 2 pi over 2 times x, so 2 times 1, 2, plus cosine y, well cosine y is 2 pi, okay, or sorry, cosine y is cosine pi, which is negative 1, so 2 plus negative 1. Okay, well I can simplify that pretty easy. That becomes 1, if I'm not mistaken. Unless I made a mistake somewhere, which if you find that out, please let me know. That'd be great. Alright, so negative 2 pi over, this is essentially 1, so equals negative 2 pi. So what is that's your slope. The output of the derivative is the slope of the tangent line, so you could say negative 2 pi is the slope of the tangent line. Okay. This brightness it must be getting brighter in this room. And then I need an equation of the tangent line. So y minus y1 equals m times x minus x1. There's your x1 and your y1 up there. So you got these already. You can list them. x1 equals 1, y1 equals pi, and your slope is the output of the derivative. Oh, I'm sorry. Your slope is the output of the derivative, and your output of the derivative was negative 2 pi. Okay? Alright, so inputting all those three things, you get y minus pi equals slope negative 2 pi x minus 1. And now, that definitely deserves a boom. No, you don't have to get y by itself. We don't do that. Okay? There we go. Alright, that's it for number 1. Let's move on to the number 2. Alright, so number 2, I'm going to have to erase number 3, but number 2, you've got your first, you've got your second, you've got your first, and you've got your second. So you have two product rules, okay? So here we go. Derivative of the first times the second plus derivative of the second times the first. Derivative of the first is 1 times the second sine 2y plus derivative of the second. And that's a chain rule. The outside is sine, so it becomes cosine. Keep the inside, and now I derive the inside, which is derivative of 2y is 2y prime. 2 is a multiplying constant, so it just tags along. Okay? So that's the derivative of the second times the first is x equals, I feel like I'm using a typewriter, another product rule. So derivative of the first is y prime times the second cosine 2x plus derivative of the second. Now that's actually a chain rule as well. Cosine 2x, the derivative of 2x, or that's more than x. So derivative of the cosine is negative sine, keep the inside the same, and times the derivative of the inside, which is 2, and this is all the derivative of the second, and times the first, y. That's a big old derivative right there. Okay, lots of stuff. Let's write it nicely before we move on. So that's just simply sine 2y plus cosine, I don't know, 2y prime. I might not be able to write this nicely. Times x equals y prime cosine 2x minus, there you go, that was something I did right, minus, I can move this 2y to the front, I guess, 2y sine 2x. Alright, so I didn't get much nicer, but let's go ahead and isolate the terms. This term has my y prime. This term has a y prime, so they need to be on the same side. Okay, so I'm going to minus this one. Okay, and so sine 2y plus cosine 2y prime x not equals minus y prime cosine 2x. I knew I would run out of a pencil. It's getting a little dull. Equals negative 2y sine 2x. Alright, so and now I've got my y primes on the same side. I need to get rid of what doesn't have a y prime. So actually I'm just going to go ahead and go underneath number 3. I'll do number 3 somewhere else. Alright, so I'm minusing this, it's gone. I'm going to get it on the other side. I'm going to have cosine 2y prime x minus y prime cosine 2x equals negative 2y sine 2x minus sine 2y. Wow, that's a lot. And now I've got my y primes on the same side, so we can use the greatest common factor technique to factor those out. Y prime factored. Now I can move this 2 and this x out of the front just because I can. 2x cosine 2y minus cosine 2x equals negative 2y sine 2x minus sine 2y. Okay, I need to zoom out a little bit. This is getting a little ridiculous. There we go. Now this is all a multiplying factor, so I'm just gonna divide everything. So y prime equals negative 2y sine 2x minus sine 2y all over 2x cosine 2y minus cosine 2x. Alright, now we were given that point at the very beginning. See, we're done. Woo! That deserves a big old boom. Okay? And I'm going to attach this paper. Alright, there we go. Yeah, right at the top. Alright. So, yeah. So what we have here is now a derivative, which we can plug a point into to find the slope of the tangent line. So our point was pi over 4, pi over 2, and so yeah, you have to plug pi over 4 in for every x. So that's going to give you negative 2. Well, and then pi over 2 for every y as well. Okay, so that's going to give you negative 2 times pi over 2. Hold on. Negative 2. And yeah, you don't have to write all this out. You can just kind of do it in your head. You know these are going to cancel. And then sine 2x. Well, 2 times pi over 4 is pi over 2, so the sine of pi over 2 is 0. Wait, 1, sorry. Sine of pi over 2 is 1. Minus the sine of 2y, well, let's see what that is. The sine of 2 times pi over 2, 2 times pi over 2 is pi, sine of pi is 0. So that's minus 0. All over 2x, 2 times pi over 4, which is that, I'll just write it, 2 times pi over 4, simplify it later. Cosine 2y, 2 times pi over 2 is pi, cosine of pi is negative 1, minus cosine 2x, pi over 4 is 2 times pi over 4 is pi over 2, and the cosine of pi over 2 is 0. So y prime equals, you can't cancel those. Actually you can, because those are gone, but I would rather just simplify, cancel here, and 2 times pi over 4 is pi over 2. So you end up with pi times 1 is pi. This becomes pi over 2 times negative 1, so negative. And this is pi times, flip it, negative 2 over pi, cancel. Oops. Y prime is equal to negative 2. Wow, all that boomage for just a negative 2? Are you kidding me? I think it's awesome. But, you know, you never know. Anyway, alright, so you end up with y minus y1. Oh, my bad. Here we go. Let's identify it. What did we just do? Negative 2 is the slope of the tangent line at the point pi over 4, comma pi over 2. Yeah. Alright. So, and now I'm going to do the tangent line equation. Y minus y1 equals m times x minus x1. And then, so y minus, that's y, pi over 2, equals slope, that's the slope, negative 2, x minus, that's x, pi over 4. And yeah, that deserves another boom as well. So does this, because it's so simple. And yeah, we just got major boomage everywhere. Alright, so that was pretty cool, right? Such a simplistic answer to a tangent line equation to a monstrosity of a derivative. Yeah. Okay, that's all I can say about that. Alright, number 3. We kind of ran roughshod all over it. So I'm going to write it on another sheet of paper right here. Okay, so x squared y squared equals 9 at negative 1 comma 3. Alright, so, oh, and by the way, I'm going to do a side-by-side comparison to your next review in a minute, so you might want to stay tuned. Man, 4 pages down, how about that? So what we have here is thing 1 times thing 2. So we have a product rule, and that is just a constant, but you can imagine x to the 0 power, so thing 1's derivative is 2x times thing 2, y squared, plus thing 2's derivative is 2y prime, and thing 1 is x squared. Wow, this looks like a piece of cake compared to the other ones, doesn't it? Alright, so this is what I'm looking for, eye on the prize. I'm going to minus this over, so I end up with 2y prime x squared equals 2xy, and then there's my y prime. It's a little funky looking. I could just, right there, commutative property, yeah? 3 times 2 is the same as 2 times 3. That's what I just did. Alright, now this is a multiplying thingy, so the opposite is division. So divide that thingy, you get 2xy over 2yx squared. Well, here some nice cancellation occurs, so it's pretty cool. You get your y's canceling out, one of your x's. So y prime is equal to, sorry about that, and the 2's cancel. So you end up with 1 over x. Huh. Who'd have thought? 1 over x. So simple. Alright, so let's plug in your x and your y into your derivative. Well, here you only need x. So your x is negative, x is negative 1. 1 divided by negative 1 is negative 1. Another simple answer, well, to a simple derivative. So verbally what this means is negative 1 is the slope of the tangent line, to f of x, or to the function, or to that. Negative 1 is the slope of the tangent line to that at negative 1 comma 3 at that point on the graph. Okay. Now we can do an equation very easily. Y minus y1 equals m times x minus x1. Alright, y1 is our 3. M is negative 1. And x is negative 1, so that becomes x plus 1. And that deserves a boom, because we're done. Alright, so I'm going to do a quick side-by-side comparison to your problems on your new problem set that you should be working on this weekend. But I'm going to do it in a new video, so you'll check out the next one I post in a little bit. Alright, peace.